In this video, we will share our perspective of volume and engine displacement as it relates to scale models. To begin this video, we will use a cube to help us measure volume. Continuing on our video series on scale, then calculating area, now we will discuss volume and calculate engine displacement. We can see that this cube has the measurements of 1 inch length, 1 inch width, and 1 inch height. Volume of a cube is calculated by multiplying length, width, and height. If each of these measurements is 1 inch, then the cube will have a volume of 1 cubic inch. We will now demonstrate this again with a smaller cube. The smaller cube has the measurements of 1 centimeter length, 1 centimeter width, and 1 centimeter height. If each of these measurements is 1 centimeter, then the cube will have a volume of 1 cubic centimeter. As a side note, 1,000 cubic centimeters is equal to 1 liter. We've now defined units of measurements and calculated for volume of a cube. We will now talk about the volume of a cylinder or cylinder volume. Cylinder volume is the amount of volume in a single cylinder that is displaced with a piston. In this view, we can see a circle which would represent the top view of our cylinder. Considering that this is the top view of our cylinder, bore is the diameter of the cylinder. As seen, the bore in this example cylinder is 101.6 millimeter or 4 inches. To calculate cylinder volume, we will need the measurements for the bore of the cylinder and the stroke of the piston. Now we will measure the stroke of the piston in this example. The stroke is the measurement of height or distance that a piston moves between top dead center and bottom dead center. As a side note, top dead center is when the piston is at the top of its stroke, and bottom dead center is when the piston is at the bottom of its stroke. Now we will measure the stroke of this example piston. This example piston has a stroke of 88.392 millimeters or 3.48 inches. Here is the bore and stroke of this example cylinder. Now that we have the bore and the stroke, we can use them to measure cylinder volume. Volume for the cylinder will only need 2 measurements. This is because the cylinder has a circle shape and bore is the diameter for the cylinder. With area or volume for a circle or a cylinder, we can use pi, which can be shortened to 3.14. Pi is the ratio of a circle's circumference to its diameter. A longer version of pi is seen here, but keep in mind that in decimal format, pi never ends. Pi will be used in the formula that we're going to use to calculate engine displacement. Engine displacement is the total cylinder volume including all cylinders in a piston engine. Engine displacement is usually measured in cubic inches, cubic centimeters, or liters. To keep this simple, we'll say that we're only measuring engine displacement for one cylinder. Here is one formula to calculate engine displacement. We can see that this formula includes pi to help us calculate cylinder volume. If we simplified this formula, it would read as engine displacement equals engine cylinder volume multiplied by the number of cylinders. So now using our measurements in the formula, we can estimate the displacement for the example engine. Let's consider our example engine to be 1 cylinder and at a scale of 1 to 1. Our 1-cylinder engine would have a displacement of 716.622 cubic centimeters or 43.73 cubic inches at a scale of 1 to 1. Now that we've calculated displacement, let's take scale into consideration. In this view, we have an engine that's scaled at 1 to 1 as compared to a scale of 1 to 10. Please keep in mind our previous video discussing in detail about scale. That video will be linked in the description. This table compares dimensions of our 1-cylinder example engine. As seen, we have the dimensions at a scale of 1 to 1, 1 to 10, and 1 to 64. We can see that at a scale of 1 to 10, the engine has a displacement of 0.7166722 cubic centimeters or 0.000016682 cubic inches. By looking at this data, we can see that when scaling engine displacement, the bore and stroke must be scaled first and then the engine displacement calculated from the scaled dimensions. This table demonstrates the dimensions for the example engine converted into a scale of 1 to 1 and 1 to 64. You'll notice that in this table and at these two scales, we have a 1-cylinder engine and an 8-cylinder engine. So in this table, we can see how multiple cylinders affect engine displacement. The 8-cylinder engine would have a displacement of 5732.997 cubic centimeters or 349.8477 cubic inches at a scale of 1 to 1. When scaled down, the 8-cylinder engine would have a displacement of 0.02186,957 cubic centimeters or 0.00133,456 cubic inches at a scale of 1 to 64. For those who think these dimensions are familiar, these dimensions match the General Motors or Chevrolet small block, which is marketed as a 350 cubic inch or 5.7 liter engine. Although theoretical, we hope that these examples have been a good introduction of how to calculate volume, engine displacement, and scale them down as related to scale models. This video is similar to one that we made on the Brick Barn channel. While that video was focused on LEGO minifigure scale, this video will focus on scale models in general. That video will be linked in the description. Thank you for watching.